In this module, we will gather all the survey data needed from our project area using the GPS equipment that was shown in Module 1. Ideally, we would like to take a large number of points, in the thousands or even tens of thousands, to fully characterize the topography of this area. However, this is neither a practical nor economical way to survey. To collect the appropriate amount of data to create a useful topographic map, we need to have a grid of equally spaced data points. This ensures that all the triangles used in the triangulation of these points will be of a similar size. Today, we will use a grid of 36 points in a 6x6 orientation. In order to space these points appropriately, we first pace out the outer boundaries of the survey area. While pacing is a crude measurement, it is quick and easy to do. Furthermore, the actual position of these points is not as critical as simply having the points spaced relatively evenly over the project area. For this area, we noted that the length was 40 paces and the width was 35 paces. To create a 6x6 grid of points, we will space our points 8 paces apart within a row and 7 paces apart between rows. We will begin at a corner of the project area. Since this is point A1 on our grid, we can designate this as the description code of this point by clicking the information icon in the lower left of the screen and entering A1. Noting that the satellite indicator bar is green and the GPS rod is level, the first point is measured by pressing the Enter key on the keypad. This point is automatically given the point ID of 100, as it is the first point of this job. The point description code is saved as A1. We will note that the east-west coordinates and the elevation of the point are shown on the screen after this point is measured. Since we are going to measure row A first, we pace 8 paces along the direction of row A and measure the next point. Ensuring that the satellite indicator bar is green and the GPS rod is level, this point is given the code A2 and then measured. We continue for another 8 paces along row A and measure point A3. This is continued down the rest of row A. Now that we have completed row A, we are ready to transition to row B. To do this, we simply pace 7 paces in a perpendicular direction to row A, and now we're in row B. Ensuring that the satellite indicator bar is green and the GPS rod is level, this point is given the code B6 and then measured. This is point B6 since we are using a back and forth pattern for moving between rows in this survey. We can now pace 8 paces in row B and measure point B5. This process is repeated for the rest of the rows until all 36 points have been measured. At this point, all 36 points in our 6x6 grid have been measured and recorded in our GPS unit. Before we complete this survey, we must first assess whether all critical features of the terrain have been measured. If there was a sharp decline and subsequent rise in the terrain, for example a hole, in between data points of our grid, it is possible that the contour map would not show this feature. Also, it is best practice to ensure that points observed as the highest and lowest points in the terrain are measured, if they were not already captured by our grid points. For this example terrain, additional points have been used. Around the utility building, in order to locate the building properly on the contour map, the 4 corners of the building were measured. These points are labeled Build 1 through 4. 4 extra points were also used in the lowest points of the bowl surrounding the utility building in order to capture the extents of the lowest area of our terrain. These points are labeled X1 through X4. This concludes our work in the field. The next module will show you the result of our survey work and the benefit of using some of the extra points that we surveyed at the end of our session.